Alright everyone, today we're going to be looking at work. So this is going to be the first lesson of Unit 2 and these questions will come back, but let's take a look. So we know our formula is defined as work is equal to force times displacement, right? The tricky part about this question or these types of questions is you won't always be given force directly. You won't always be given like force is equal to 20 newtons or something like that. You're more often going to just be given the mass and have to calculate force. Okay, and it'll ask you what force is. So before we even get into this question, let's look at something like that, where they tell you the mass is 10 kilos, and we're on Earth, so we know the acceleration due to gravity is always going to be 9.8 meters per second squared. Cool. So if I were to lift a 10 kilogram box, what is the force I apply to move it up? Uh, let's say 3 meters. Okay. So the way we would go through a question like this is we would go into our given and we'd say, okay, our mass is equal to 3 kilos. We know the acceleration due to gravity is 9.8 meters per second squared. So that's the acceleration I also have to overcome when I lift it. And we also know acceleration, mass, and displacement is 3 meters, right? And this question will be asking us to find the work done on the box by me when I lift it. So work or applied work, and we're just going to solve that by going work is equal to F times D, but we need F first. So we know F is equal to mass times acceleration. So now we can solve it. Force that I apply to this box is going to be the mass of the box, 10 kilos, times the acceleration due to gravity. And remember, it's positive because in order to lift the box, I have to accelerate at 9.8 meters per second up, right? If we're asking the work done by gravity, it's going to be negative, but we'll get into that, okay? Anyway, this will be 98 kilograms times meters per second squared, which is also equal to 98 newtons, okay? Once we have the force, we can fill in work. So work is equal to force times displacement. Force is 98 newtons. And then we know displacement was 3 meters. So now we can do 98 times 3, so do 300 times 300 minus 6 is 294 Newton meters. And we're usually going to define work in joules. So Newton meters is the same thing as joules, so we're going to write 294 joules was the work I did on this box, okay? So I'm going to say, okay, the work applied here by me was equal to 294 joules. That is how much work it would take to lift this box 3 meters. But what is the work being done by gravity? Well, there's two ways to find this. One of Newton's laws says that all the forces must have an opposing force in the opposite direction, but also we can calculate it the same way. But this time we're going to calculate force not applied, but force of gravity. And force of gravity, we're going to have the same mass, that didn't change. But now gravity is accelerating us downwards, so we have meters per second squared. And we're just going to have negative 98 kilos per meter squared. And we can do the exact same thing, except now, since our force is negative, our work is also going to be negative. And we're going to solve it 294 joules, and don't forget to make it negative. Okay, so now we know that the work done by gravity on this box is equal to negative 294 joules. Okay, and the network, or the total work being done to this box, is 0.